Environmental Sciences, short notes, environment, definition, and components. Definition. The environment is the entire physical and biological system that surrounds life, encompassing all living and non-living factors that influence organisms. Main components: abiotic, non-living, soil, air, water, temperature, light, climate; biotic, living, plants, animals, microorganisms. Importance of physical environment. Determines habitat conditions, human settlement, agriculture, health, and development. Key factors: climate, soil, water availability. Environmental thought in political theory. Montesquieu's climate theory. Climate shapes human behavior, societal development, and political institutions. Temperate zones are most favorable to democracy. Key environmental facts. A large tree produces oxygen for 4 people a day. Human oxygen requirement, 0.84 kilograms per day. Total water on Earth, 1.386 billion kilometers cubed. Ecosystems and biotic roles. Ecosystem types: desert, marine, forest. Biotic categories: producers, autotrophs, green plants; consumers, heterotrophs, animals, humans; decomposers, bacteria, fungi. Social component of environment: human interaction with other species. Aristotle: man is a social animal. Activities: shelter building, food production, waste disposal. Major environmental zones: A. Atmosphere. Composition: N2 78.08%, O2 20.95%, AR 0.93%, CO2 0.038%. Layers: O troposphere 0 to 12 kilometers. Weather: O stratosphere 12 to 50 kilometers. Ozone layer: O mesosphere 50 to 85 kilometers. Meteors burn. O thermosphere 85 to 600 kilometers. Solar radiation absorbed. O exosphere merges into space. B. Hydrosphere. Oceans cover 71% of Earth. 97.5% saline, 2.55% freshwater, only 0.3% liquid surface water. Oceans hold 99% of living space, 85% deep sea, 10% explored. The water cycle, hydrological cycle. Key processes: evaporation, condensation, precipitation; runoff, infiltration, groundwater recharge; surface water, rivers, lakes. Lithosphere, Earth's solid shell, crust, upper mantle, supports ecosystems and interacts with hydrosphere and atmosphere, composed of rocks and minerals. Internal structure of Earth: crust, 5 to 70 kilometers; mantle, up to 2,900 kilometers, includes asthenosphere. Outer core, liquid iron and nickel, 2,900 to 5,100 kilometers. Inner core, solid iron to 6,371 kilometers. Environmental science. Definition and objectives. Definition: multidisciplinary field studying interactions among physicochemical and biological components of the environment. Objectives: understand natural cycles, water, carbon, nitrogen. Study human-environment interactions, e.g., mining, urbanization. Mitigate environmental damage, e.g., pollution, biodiversity loss. Interdisciplinary nature of environmental science. Discipline: focus natural sciences, biology, biodiversity, chemistry, pollution, geology, minerals. Social sciences: geography, resource use, economics, valuation, political science, laws, treaties. Humanities, philosophy, ethics, environmental ethics, literature and media narratives. Ecofeminism links gender oppression with environmental degradation. Key thinkers: Mary Mellor, Vandana Shiva, Maria Mies. Themes: patriarchy oppresses both women and nature. Greta Gard and Lori Gruen, 2005, gendered environmental injustice. Grassroots, justice-based approach advocated. Environmental microbiology, study of microorganisms in natural engineered settings. Key roles: nutrient cycling, e.g., nitrogen fixation, bioremediation, microbes in extreme environments. Tracking pathogens, e.g., COVID-19 mapping. Environmental economics, studies economic-environment interactions. Core concepts: valuation, assign value to nature. Externalities: carbon tax, pollution permits. Sustainable development, balanced growth. Environmental biotechnology. Definition: use of biological systems for environmental restoration. Applications: bioremediation, biogas production, composting, green manufacturing. Benefits: reduced emissions, ecological restoration. Climate change definition, IPCC. Change in the state of the climate that persists for decades or longer, identified via statistical tests. Causes: natural, volcanoes, sunspots, El Nino. Anthropogenic, fossil fuels, deforestation, agriculture, industry. Historical timeline: 1712, steam engine, Newcomen. 1896, Svante Arrhenius proposes CO2 warming link. 1957, Ravel and Suess, oceans can't absorb all CO2. 1988, IPCC formed global warming versus climate change. Global warming, rise in surface temperature. Climate change encompasses all changes in precipitation, sea level, etc. Major greenhouse gases, GHGs. Gas features CO2 plus 50% since 1750. Fossil fuels. Cement CH score 25 stronger than CO2. GP. Livestock, landfills N2O, 298 GWP. Fertilizers, biomass burning F gases. CFCs, HFCs, very high GWP. Refrigerants, aerosols. Climate change indicators, plus 1.1, 1.2 degrees C warming since 19th century. Sea level rise, ice loss, Greenland, Arctic. Super typhoons, e.g. Haiyan. Heat waves, e.g. Karachi 2015. Pakistan floods 2010, 2022. Pakistan's vulnerability. Glaciers, Himalaya, Karakoram. Monsoon variability, Glofs. Coastal risks, Karachi, Thada, Aden. Impacts on Pakistan, crop failures, rural poverty, flood damage to infrastructure, urban heat stress. Pakistan's climate initiatives, international participation, UNFCCC 1994, Kyoto Protocol, Paris Agreement, Vienna Convention 1985, Montreal Protocol 1987, Kigali Amendment 2016. National measures, Climate Change Act 2017, Climate Council Plus Authority, GCISE research body, 10 billion tree tsunami challenges, fossil fuel heavy energy policy, weak coordination, low funding, climate often deprioritized. Global Environmental Agreements Treaty, key points. Vienna Convention 1985, Ozone Framework led to Montreal Protocol. Montreal Protocol, 1987, phased out. 96 ozone depleting substances. Kigali Amendment, 2016. HFC phased down Rio Earth Summit, 1992. Created UNFCCC CBD Agenda 21, Forest Principles. Kyoto Protocol, 1997. Binding targets for Annex 1 countries, criticized for exemptions and outdated baselines. Paris Accord, 2015. Universal Voluntary Pledges NDCs aim to limit warming to 2 degrees Celsius, 100 by year fund promised. Evolution of environmental movements. Conservation phase, 1900-1910. Elite-led, parks, forests protected, moral and aesthetic concerns. Ecological consciousness, 1960 to 1973. Silent Spring, Rachel Carson. Limits to growth, Club of Rome. Small is beautiful, Schumacher. First Earth Day, 1970. Stockholm Conference, 1972. Modern Environmentalism, 1987 to 1993. Brundtland Report, 1987. Sustainable Development, Rio Summit, 1992. UNFCCC, CBD, Agenda 21. Emphasis on Global Responsibility, CBDR. Postmodern Environmentalism, 1994 present. Themes, Circular Economy, Environmental Justice, Resource Rights. SDGs, 2015. Goals 6, 7, 13, 14, 15. Stockholm Conference, UN 1972. First major UN conference on environment. 113 countries, 400 plus NGOs. USSR boycott. Outcomes. Stockholm Declaration 26 principles. Creation of UNEP, HQ Nairobi. Triggered Brundtland Commission. Rio Food Security. UN definition. Access to sufficient, safe, nutritious food for all people at all times. Global food sources. Crops 76%. Rangelands, meat 17%. Fisheries 7%. Current status. 870 million undernourished globally. 14.8% in Southern Asia. By 2030, cereal demand 50%, meat demand 85%. Climate change impact, food gap report, output shortfall by 2020. Production decline, wheat gas 14%, rice 11%, maize 9%. Africa, 50% yield loss, rain-fed crops. Sustainable agriculture FAO definition. Preserves land, water, genetic diversity while being socially and economically viable. Impacts of agrochemicals, fertilizers, eutrophication, water pollution, soil degradation, pesticides, resistance, health risks, beneficial species loss, sustainable techniques, organic farming, biofertilizers, rhizobium, azotobacter, vermicomposting, IPM, integrated pest management, mixed cropping, crop rotation, soil conservation, agroforestry, terracing, reduced tillage, INM, integrated nutrient management, new urban management, major urban problems, congestion, pollution, solid waste, land scarcity, rural urban migration, urban sprawl and unplanned growth, principles of sustainable urbanism, economic, cost efficiency, environmental, low emissions, green spaces, resource management, renewable use, social, affordable housing, public services, regenerative design, use replenishment. Key interventions. Mixed use development ends zoning separation, encourages walkability. Public transport, BRT systems, e.g. New York BRT lowers car use. Real estate control, emphasize vertical growth to preserve farmland. Managing rural urban migration Intermediate cities, 250,000 to 1 million population. Punjab's Intermediate Cities Program, ADB 600 Basic services in rural areas. Schools, RHUs, housing, roads. Agriculture and SME uplift. Empower small farmers, rural industries, technology access, high yield and climate resilient seeds. Case study California Smart Growth Metric. Unplanned, smart growth land use 6,000 acres, 1,700 acres. Emissions high, low. Vehicle miles HH 28K year, 16K year. Cost 22 year, 9K year. Projected savings 2035, $1.66 per year. Environmental management approaches, technological approach in national parks, wildlife reserves, conservation, recycling, clean energy, restoration, reclaiming degraded lands, purification, air and water treatment, renewables, solar, wind, biomass participatory approach, degrees, passive, information, consultation, contribution, partnership, self-mobilization, environmental management systems, EMS, definition, a structured framework to monitor and improve environmental performance, PDCA cycle. PDCA cycle, plan, do, check, act. Core principles, legal compliance, staff training, key performance indicators, KPIs, continuous improvement, benefits, cost reduction, legal safety, resource efficiency, positive public image. Example, OSHA, US 1970. Hazard categories, safety, equipment, biological, pathogens, chemical, toxins, physical, noise, radiation, ergonomic, design flaws, organizational, stress, harassment. Environmental Impact Assessment, EIA. Definition, a pre-project evaluation of environmental, social, and health effects. Origins, institutionalized post-1960s ecological disasters. Objectives, integrate environment into decision-making. Prevent irreversible damage. Promote sustainability. Assess mitigation options. EIA process, 8 steps. Screening, scoping, terms of reference, baseline data collection, impact prediction, alternatives assessment, mitigation planning. Environmental Management Plan, EMP, reporting and decision making. Strategic Environmental Assessment, CA. Definition, applies environmental review to policies, plans, and programs, PPPs, before they're implemented. Objectives, protect ecosystems early, address cumulative effects, integrate into high-level planning, reduce duplication with project-level EIA process. Screening, scoping, environmental reporting, stakeholder consultation, decision making and implementation. Comparison, EIA versus SEA. Scope, project level, policy plan level. Time horizon, short-term, long-term approach. Reactive, proactive participation. Limited, broad focus, site-specific, cumulative, systemic.